We begin our cosmic voyage pondering the enigma that shrouds the origin of our universe. Picture a time around 13.7 billion years ago. A time when there was nothing, not a single atom, not even space or time existed, yet in a split second, the universe as we know it began to form from this nothingness. A concept that challenges our very understanding of reality. This moment, often referred to as the Big Bang, marked the birth of the cosmos. But here's the intriguing part. We're still not entirely sure what, if anything, existed before this defining moment. Was there a different universe, another reality, or simply an expanse of absolute void? These profound questions continue to puzzle even the brightest minds, highlighting the enigmatic beauty of our universe's origins. And just like that, in a spectacular instant, the cosmos began to take shape. Now, let's unravel the mystery of the Big Bang. This term often conjures images of a massive explosion, but let's clear up a common misconception. The Big Bang wasn't an explosion in the conventional sense, it was the very birth of time and space. In the beginning, the universe was an incredibly hot and dense point, smaller than an atom. Then in less than a blink of an eye, it began expanding. This expansion, still happening today, gave rise to the cosmos we know and love. It's like the universe took a deep breath and started to grow. However, the exact nature of this cosmic inception still eludes us. What sparked this expansion? What was there before? These questions tease the minds of astronomers and physicists across the globe. What happened precisely at the very beginning remains one of the greatest cosmic mysteries. Soon after the Big Bang, the universe underwent a rapid expansion known as cosmic inflation. This wasn't just a leisurely stretch, it was a mind-boggling exponential ballooning of space itself. It was like a cosmic sprint, with the universe expanding faster than the speed of light. But why did this happen? Well, it's believed that a mysterious force field filled the universe, causing this rapid inflation. As the universe expanded, this field decayed and released energy, creating the hot, dense state we associate with the Big Bang. So what was the result of this cosmic inflation? It led to the creation of structures like quasars. These are incredibly bright galactic nuclei, emitting beams of light so powerful they're visible from billions of light years away. These cosmic lighthouses are among the earliest structures to form in the universe, providing us with a glimpse into the cosmos's distant past. This era of expansion set the stage for the evolution of our universe. The cosmic inflation period, though brief, had profound and lasting effects, shaping the universe as we know it today. Fast forward to the birth of our solar system. Picture a vast, nebulous cloud of gas and dust in the early universe. Over time, gravity pulls this material together, causing it to collapse under its own weight. As the cloud shrinks, it spins faster and flattens into a disk. At the center of this disk, a protostar begins to form. As the protostar accumulates more and more matter, its temperature rises, sparking nuclear fusion. This is the birth of a star, our sun. Around this newborn star, the remaining cloud of gas and dust continues to orbit in the disk. Over tens of millions of years, solid particles within this disk start to stick together, forming planetesimals. These planetesimals collide and merge, growing into the planets we know today. This process, hidden from our direct view, has left us with the sun at the center of our cosmic neighborhood. Now let's delve into the mysteries of hidden dimensions and the ongoing search for extraterrestrial life. As we ponder our place in the universe, we must also consider the possibility of dimensions beyond our familiar three. These uncharted dimensions, as elusive as they may be, could hold the key to unifying the fundamental forces of nature. They're like the missing pieces of a cosmic puzzle waiting to be discovered. Imagine a universe where gravity is not limited to our three-dimensional world, but seeps into these hidden dimensions, potentially explaining why it seems so weak compared to other forces. Now let's shift our gaze towards the endless expanse of space, where the search for life beyond Earth continues. With the Kepler telescope's discovery of thousands of exoplanets, many within the habitable zones of their respective stars, the potential for life as we know it has significantly increased. Picture, if you will, a world where life has adapted to conditions vastly different from ours. Perhaps life forms that thrive in the frigid conditions of a moon orbiting a distant gas giant, or organisms that gain energy not from a star, but from the geothermal heat of their home planet. The search for such life forms is a complex and challenging endeavor. It requires not only sophisticated technology, but also an understanding of how life could evolve under different circumstances. Scientists are using advanced telescopes to look for signs of life, such as changes in the atmosphere of these distant worlds that could indicate the presence of biological activity. Yet, despite these efforts, we have yet to find definitive proof of life beyond Earth. This doesn't mean it doesn't exist, but rather that we are still developing the tools and knowledge necessary to detect it. The universe is vast, and we are but a tiny speck within it. The question of whether we are alone in the cosmos remains one of the most profound mysteries of our time. As we journey deeper into the cosmos, we encounter the enigmatic realm of black holes. These celestial entities are the cosmic equivalent of an enigma, wrapped in a mystery, shrouded in an abyss. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape their pull. They are the ultimate cosmic chameleons, changing their appearance based on their surroundings. At the heart of a black hole lies the singularity, a point where the laws of physics as we know them break down. This singularity is thought to contain infinite density, compressed into a space of zero volume. It's a concept so extreme it's hard to wrap our heads around it. But black holes are not the only marvels in our cosmic neighborhood. Our very own sun, the life-giving star at the center of our solar system, is a hotbed of solar phenomena. It's constantly churning out solar flares and coronal mass ejections, which are essentially giant bubbles of gas and magnetic fields ejected from the sun. While these solar phenomena are fascinating to observe, they can also have significant impacts here on Earth. In fact, a large enough solar storm can disrupt our technology. The Quebec blackout of 1989 is a prime example, where a solar storm caused a 9-hour power outage. But let's take this a step further. Let's imagine if a colossal solar storm, like the Carrington event from the 1800s, happened today. The Carrington event was the largest solar storm on record, and its effects were felt worldwide. Telegraph systems failed, auroras were seen as far south as the Caribbean, and some reports even claimed that people could read newspapers by the aurora's light. If such a storm were to occur in our modern interconnected world, the consequences could be staggering. Our power grids could fail, satellites could be damaged, and our digital lifestyle could come to a grinding halt. So as we continue to explore the cosmos and uncover its secrets, let's not forget the power and mystery that is right on our doorstep. Imagine if a colossal solar storm like the Carrington event from the 1800s happened today. The consequences could be staggering. Our universe is a tapestry of over 200 billion galaxies, each unique, immense, and dynamic. The sheer number of galaxies in the universe is mind-boggling. These celestial cities, teeming with billions to trillions of stars, are scattered across the cosmos, each holding its own unique set of characteristics, mysteries, and charm. From spiraling galaxies like our own Milky Way to elliptical and irregular ones, the diversity is simply astounding. In every galaxy, countless stars twirl around their central hubs, each held in place by gravity's invisible threads. Some galaxies are so vast that they contain more stars than there are grains of sand on all the beaches on Earth. Just let that sink in. But what's even more fascinating is what we can't see. The universe, it seems, is hiding something from us. Enter dark matter, the universe's enigma wrapped in a cosmic conundrum. It's invisible, yet its gravitational influence is seen everywhere, from the rotation of galaxies to the bending of light from distant stars. Scientists believe that dark matter, which doesn't interact with light or other forms of electromagnetic radiation, makes up about 85% of the universe's total matter. Yet, despite its prevalence, this elusive substance remains one of the greatest mysteries of modern physics. The search for dark matter is like a cosmic detective story, with scientists using every tool at their disposal to uncover its secrets. From underground laboratories to space-based observatories, the hunt is on. And while we have yet to detect dark matter directly, its gravitational effects on galaxies and galaxy clusters provide indirect evidence of its existence. So imagine for a moment the vastness of our universe with its billions of galaxies, each with its own unique story to tell. Now add to this the mystery of dark matter that pervades every corner of the cosmos, influencing the very fabric of space and time. It's a grand cosmic ballet, choreographed by the laws of physics, playing out on an unimaginable scale. The universe, with its galaxies and dark matter, continues to mesmerize us, leaving much to be revealed in the future.